Hi, some of you may have seen my AI-9 jet engine videos before, but today I'm going to go through a build. This is the engine that's actually we're going to see by the end of the day. At the start of the video it'll all be in pieces. One problem I came across, it's rather a long build. It lasted 3 days, so I'm going to split the video into 3 parts. So this is the engine we're going to be looking at. It's a single stage gas turbine used by Russian military and commercial airlines. It's around about a 50-year-old design there, so a lot of these engines that have been in circulation have been changed for electric starter motors, because this is basically what it is, a starter for the larger engines on aircraft and helicopters. The idea of the actual machine is we've got a valve down here, which is the key part of this engine. It actually spins up to a core speed of around 40,000 RPM, and once it really gets going, we can open this valve and that will produce massive amounts of airflow. And the idea of that gets piped down to the big engines, and that will spin the turbine blades in those, and it will start each engine. It's used to start each engine in turn. With this being the older model, the newer ones actually have a generator on the back and can be used to generate power for batteries and what have you. Yeah, I got a pair of these engines. I've been demonstrating one for a while that I've actually built. This is the one that needed a bit of a rescue. Made components for it. I've got my own little workshop, and we've actually made different casings, some aluminium castings that we've made up. There are some special bearing seals, high temperature bearing seals that we've made. We've made an airplane chamber cover, which is this one here, green part. So we've made quite a few different bits and pieces, and this is the culmination. I haven't started it yet. That'll be another video that comes later. So yeah, take your time, watch the video, see what you think. As many of you know by now, I've started stripping down my AI-9 APU jet engine. It's all in parts. It's been like this for about a year now. Boxes of bits, parts all over the place. I've still got to get my act together and get this sorted. I've just about finished with the last components on the lathe. I managed to get a pair, one of them being completely knackered, and that's the one I'm rebuilding today, and the other one was in reasonably good condition. We were going to use the second one as the donor machine. But what we've had to do with this is make a lot of parts. The casing, which is the plenum chamber, had to make this as well. That's all made of aluminium. Unfortunately, the air valve, the KP9 I think it is, was actually snapped off and missing, and miraculously I managed to find one on eBay being described as a part of a Russian spacecraft. I recognised it and managed to get it for about 60 quid, so that's good. Part of quick cleanup, and that's back on here. I've had a few little problems with the engine. There was a few fatigue issues where we found some cracks. I've had some special welding done to clean that up. Also, quite a few of the castings were broken off, and it does help to have one of these manuals so you can know what you're working with. So the manual that I've put back together, this was originally all in Russian. It's now in English. If anybody actually wants a copy, just drop us a message and I'll sort you out. Inside the I've created my own control system running off something called an Arduino. So again, if anybody needs that information, that should all be in here. I can get the software and the control systems. One part was particularly tricky was the oil casting was, like I said, was snapped off and missing. So I ended up actually saying, what do? You're an engineer. You can either give up and throw the thing in the bin and leave it to another day, or actually try and make your own. And that's what I came up with. I had an original one that I could actually use as a pattern. It's got an oil filter in the center as well. It's probably as good as the original. We are talking Russian technology, but it's all got the correct thread, and that was made out of a billet of aluminium. And to make it look a little bit more sort of fitting, it was sandblasted to give it that sort of casting look. As well as that, there's a few other bits and pieces I've had to make as well. One of the key things that you need to be aware of if you're playing with jet engines is the older ones tend to have asbestos. And when I took one of these things apart here, I've actually found something. It generally looks like some sort of material. Don't play with it, just leave it alone. If it's falling apart, you've probably come to the end of the line with the thing. But on this engine, when we took the case off, it still looks as if it's in good condition. It's not flaking, it's not falling apart, so we don't want to touch that. All we'll do is just carry on and rebuild around it, and that will probably last, at least for our test purposes at any rate. Okay, so what do we need to do first? I would certainly think about making sure you're using clean utensils. I've got some stainless steel fat pans for cooking. No, I didn't steal them off the missus. These are off eBay, probably useless for real cooking, but absolutely ideal for engine cleaning and components and things like that. All the rest of the parts I've got have either been patched up, re-welded, all the sort of stuff you could normally get by and do yourself. So here they are. Remember, these materials are probably exotic metals. They don't always weld as easy as you thought they would. Unfortunately for me, the outer casing is just standard steel. But if the combustion can had actually cracked or something like that, I think we'll be either looking at riveting or potentially maybe arc welding or spot welding to do a repair. Okay, so first off, we'll put the flame arrestor. This stops the actual heat from where combustion's happening, pressing back and heating more pipe work. There's also a asbestos heat shield in there as well. And when we originally took this out, we noticed a small crack here. Now if we'd left the crack in with the vibration, that crack would have actually carried on all the way up and actually completely ended our story on this one. So first of all, let's get this in. So I'm just going to tweak these nuts up now, all by hand. I don't want to use anything special. Sometimes to try and get tags up can be a bit of a pain. Now I use a wood chisel, just a little tiny bit on each one, just enough so you can get your eyes or whatever you're going to use underneath final tight. We'll be fitting some gaskets in a minute after I've cleaned up. Just a quick thought about gaskets. I always keep my old ones. I know they look a bit disgusting, but the idea is that I can actually start measuring them up and draw CAD images of them. Once you've done that, you can then cut your own gaskets, and these are new ones. I did this with a plotter, replaced the pen with a knife, and as you can see, it makes quite a good job, hence why we keep the old gaskets. Done the various fuel system gaskets as well, and also where you've got a lot of high heat, because again that can sometimes phase people. You can't use normal gaskets. We've got this asbestos free, and I managed to get this off eBay, and again similar sort of thing, cutting the gaskets out. But anyway, that's what we're going to be fitting. See how this fits over, and this should fit on there, as you can see. It's just because I haven't poked out the gasket yet. What we're going to do next is these little tiny holes here. These are oil injectors. They actually spurt oil directly at the bearing whilst it's running. So I'm going to reverse fill that with isopropanol. And I normally do it with a syringe. So I fill a syringe with the stuff, and then inject it into the hole and catch it as it comes out the back end. It makes a bit of a mess, but the oil was then cleared, making sure there's no dirt that's got in there. Okay, so isopropanol. Just press it against that. Same on this one. Catch what comes out the back end because it's going to come through the oil way. I'll put the excess fluid. No need to excessively wipe because you don't want to lose any fibres in there. This is going to leak isopropyl at the back end. I can hear it coming out. Move this. Okay. Mop a bit of that up and turn things right over. Okay. Now on this particular engine there's a carbon washer that actually sits between the main bearing and the compressor wheel, and it's actually held in by a labyrinth seal. So I'm just going to take that out. It's on the top, there's like 2 small rings, and then the carbon washer. Okay, so I need to keep those in the right order so I don't put them back incorrectly. The actual bearing is actually a split race, which is a little unusual. One thing to note on them, and quite a lot of high-speed bearings, precision ones, there'll be a little marker. You can see that? A tiny V. And there'll be one on the opposite side as well. And when we're actually assembling it, those V's have actually got to be lined up, which can be a little bit tricky. Sometimes if you use a camera at one end, and so I can see what I'm doing. The actual inside there is just a hanging one of these. It's upside down, but it won't drop through because it's where the oil inlet is. It actually stops it coming loose. Just drop that back there. Leave it out for a moment. Okay, so I'm just going to inject a bit of isopropanol. Don't worry about losing this stuff. It's better to actually have clean bearings than ones with bits of muck in them. It's quite a watery compound. You can actually hear the rattle of the bearings and what have you. That's okay at the moment, because once we've actually done this, we'll put a bit of oil in. Okay, what I'm not going to do here is I'm not going to start wiping around because I've actually got the main bearing there. What I'm going to do, I'm going to use a bit of WD-40, spray a bit into a rag first to make sure we've not got anything loose. Line up the chevron plate up, put the washers back in the right order. Good. The different jet engines use different mechanisms for seals, but it's unusual to see a rubber seal here because obviously the temperature that they're running at. Tolerances are quite tight. The actual shaft that drops through will be quite close to that carbon washer that's in there, and the idea is it actually tries to stop the pressure that builds up at the front actually entering the oil way. And I've had that on a previous engine, whereas the pressure at the front found its way into the central oil ways where the bearings are. The pressure in there then blows oil out the back because you've got the same facility, there's no seal, and that actually then enters the combustion chamber. And you can actually end up with a self-fueling engine, which is actually drinking its own oil to create the actual flame front in the back. I think diesel engines call it runaway, but there you go, same sort of thing can happen on jet engines as well. Now, so we've already got the nuts in place with retainers, so I'm happy with that. That's all good. So in comes Mama's baking tray with a bit of isopropanol. I'm going to wash out the rear bearing before I actually install it. The Russian units, which is quite unusual, but again works quite well. The bearing sits in this. And this is actually allows the bearing to actually vibrate within its housing very slightly. There's an outer ring and an inner ring. And the outer ring actually has very small undulations, a bit like corrugated roofing. And that actually allows the inner ring to actually flex in and out very slightly and allowing any vibration on the bearing to be absorbed by the ring. So yeah, quite a good idea really. This one I've had to repair, a little bit of welding there. A friend of mine is a lot better welder than me, and he was able to tack these back on because we'd actually had a bearing seizure in one of them. Bearings run at 40,000 RPM, that's the standard for these, probably for an APU of this size. but full-blown jet engines that produce thrust may run in the region of about 90,000 to 100,000 RPM, so obviously they're a little bit less tolerant on vibration. Okay, so let's just wash out the bearing and then we'll put that in. Okay, so I'm going to wash out the bearing in isopropanol. Two lugs, they fit into the main cap. Look at that, there's two little lugs here, 1, 2, and that stops the outer ring from moving around, so the bearing race, the outer race, will sit fixed, so it won't actually rotate around with it. But the ring that's around the outside will allow a little bit of give. At the bottom of the cap, you'll notice there's a series of holes that actually lets the oil drain out. And like on a lot of surfaces, and I missed this quite a few times, when I first took them apart, you see this unusual looking surface here. I thought that was actually a lot of carbon buildup. That's actually a high temperature surface. I've remade this using various different materials on the lathe. Again, being an engineer, you'll come up with different ideas. This was using something called quick steel. So pasted that on, put it in the machine, and brought it back up to its original sizes, and it's good for around about 1000 degrees C. I only expect this to run around about 300 to 400 at this point. That is the only seal there is. There's no rubber seal on this at all. So let's refit the rear bearing. Okay, give it a bit of a wheel. Splash it everywhere because we need to put some sealer on the bearing cover. One finger. Right, so I'm going to clean this up. We're going to be installing the new gasket. We've got some high temperature gasket sealant which I'll generally use on the combustion chamber and things like that. But according to the details here and a lot of the old gaskets have got what looks like an aluminium coloured paste on them, which is high temperature sealant. And my translation of the Russian sealer comes to silaxan enamel, high temperature sealant filler type. Okay, so they have some aluminium powder at 250 mesh mixed with a high temperature lacquer, which in my case I'm going to be using this stuff here, which is just generally clear lacquer. So I'm going to spray that into a can, mix some of the paste up, and that in theory should give us the same sealing compound that would need to actually seal the gaskets. Let's give it a go. That's what it looks like. Aluminium and lacquer paste. What we've got to be careful here is not to put too much on, in that we end up getting it in the holes of things. It does tend to go off quite quick, this stuff. But all I want to do is just put a thin layer on before I match it against the gasket. And we've got the outer ring as well. Okay, very similar to an engine block. Do opposites. Quite important that this seals properly. So just roughly tighten up to get yourself going. Okay, right, each stage, once you've done, cover up. I'm going to go and actually have a look at the main drive shaft. I've got to actually tighten those tags. Okay, right, so the shaft that runs through the centre, that carries the combustion wheel. At this end it's the compressor wheel, otherwise known as a turbo. Okay, so for the actual spindle to be put back in, machine it, because I can't drop it straight in, because if I do all the washers fall off. And let's see if insert this without too much of a problem. Okay, so that's as far as I can get it at the moment, and that's because the actual inner races are tight on the shaft. So I'll turn the machine round so we can see the other side and see what we've got there. Okay, so I've actually lined the V's up on the bearing, and then I've actually got the shaft through. I need to actually add the little washers and what have you. Again, checking the numbers. 5304 seems correct. So that's gone first. Now, if you haven't actually put these in the right order to start with, then it's always handy to have a drawing. I just happen to have the assembly, and that gives me the correct sequence of washers and what have you. So that's what I'm building now. So here's the, and again I've got to keep the shaft pretty steady, otherwise if it moves I'm going to move those two V's. Here's the carbon washer. It's got to go in pretty straight, otherwise it won't go in at all. I'll end up breaking it. There we go. There's this packer, and that actually stops the carbon washer being crimped. Then we've got the labyrinth rings, remembering to offset the brakes. Then we've got the final cover washer. Okay, and now we need something to pull the shaft through. So we could use a tapping hammer, but I've got some of these spacers will do. And the modified socket. So all I'm doing is just tightening the shaft up, and that should pull it through the two bearings without having to use a hammer. And then for the beast, I've pre-marked this with a small pin punch there, because at the time I didn't know where the keyway was, so I've actually notched it in there. And then I'll actually line this up. Okay. So we're not far off. So what I'll do is I'll tighten that up in place, and then take the nut back off, and then add the washer afterwards. I made this mistake once before and ruined the engine. So good. Okay, back onto its side. So we've pulled it through. The bolt's about ready to be tightened. But before I do that, I'm going to put the lock washer on. I've had a bit of trouble with this before, so I'm going to put a little bit of oil on there and on here. Okay, drop that in. Put that down there. Now remember to actually align the keyway with the spot that I made earlier. I'm going to use the special socket. Unfortunately, we've got no torque settings, and I've tried doing this before with the torque wrench, and it's very difficult to hold the turbo. To actually try and hold the turbo whilst we're tightening up, not very good, it didn't work. So we'll use this. So what we're going to do is just tighten the bolt as tight as we can. And I now need to just get that tab to align. So I've got to keep going. There's still a couple of degrees to go before we're lined up. use the hammer. Good. We've got a little bit of rub because I've got new thermal seals on the back. They're like a hard, sandy material, so we can hear that. Plus the bearings are a bit dry at the moment as well. Good, okay. This is the part next, the planning chamber. This will go on like this, I believe. Yep. So what I'm thinking here is I'll probably put this on loose, turn it over, work on the other side, and then we'll come back to this in the end. But I need to make sure that this is protected, otherwise, like I say, I could run into trouble.